Take a look at this incredible view. On one side stands the Great Pyramid of Giza, and on the other, a forest of modern skyscrapers. They may seem worlds apart, but they're part of the very same engineering story. Now follow the timeline in front of you. From simple mud huts to towering skyscrapers, every civilization dreamed of building higher, smarter, and stronger than the one before. But where did that journey actually begin? Long before cities existed, families settled near rivers where fertile land could support farming. Little by little, these scattered homes began growing into something much bigger. As people lived closer together, they discovered the power of cooperation. Farmers grew food, potters made storage jars, blacksmiths forged tools, and entire communities became stronger by working together. Yet none of this happened by accident. Look closely at this map. The Nile, Tigris, Euphrates, Indus, and Yellow rivers all have something in common: they became the birthplaces of the world's earliest great civilizations. These rivers provided fresh water, fertile farmland, and busy trade routes. With irrigation canals feeding the fields and boats carrying goods, cities could finally grow and prosper. As cities expanded, so did human ambition. Rising from the desert, the Great Pyramid wasn't simply built, it was carefully engineered. Watch hundreds of workers moving enormous limestone blocks up massive construction ramps. Now look inside the pyramid. Hidden chambers, perfectly aligned passageways, and remarkably precise measurements reveal just how advanced Egyptian engineering had already become over 4,000 years ago. But Egypt wasn't the only civilization transforming city life. Welcome to the ancient city of yore. Beneath the towering ziggurat, narrow streets buzz with merchants, craftsmen, priests, and builders going about their daily lives. Climb the grand staircase and you'll discover why the ziggurat stood at the center of the city. It wasn't just a temple, it was a place where religion, government, trade, and community all came together. Around the same time, another civilization was quietly mastering something even more surprising. From above, Mohenjo-Daro almost looks like a modern city. Straight streets, neat blocks, and carefully planned neighborhoods reveal an extraordinary level of urban design. But the real innovation lies beneath your feet. Hidden under these brick streets is one of the world's earliest covered drainage systems, carrying wastewater safely away from homes long before modern plumbing. Engineering wasn't only about comfort, it was also about protection. Standing atop these mighty city walls, you can see just how carefully ancient Chinese cities were planned. Wide streets, canals, marketplaces, and watchtowers all worked together. Now focus on the city gate. Massive walls, deep moats, sturdy gatehouses, and watchtowers formed a complete defensive system that protected both the city and everyone living inside it. Some civilizations focused on defense, while others focused on bringing people together. Welcome to the Agora, the heart of an ancient Greek city. This wasn't just an open square, it was where everyday life unfolded. Look around the marketplace. People are trading goods, debating ideas, teaching students, and sharing stories. Greek engineers designed public spaces that encouraged communities to learn, work, and connect. Then came a civilization that combined many of these ideas into one remarkable urban system. Follow this Roman road as it stretches toward the city. Beside it, towering aqueducts carry fresh water across the landscape, connecting distant places with remarkable efficiency. Now look inside the aqueduct itself. Using nothing but a gentle slope and the force of gravity, fresh mountain water flowed into fountains, bathhouses, homes, and public buildings every single day. Roads and aqueducts were only part of Rome's engineering genius. From above, a Roman city looks surprisingly organized. Roads divide neighborhoods into orderly blocks filled with forums, bathhouses, markets, theaters, and public gardens. Now compare it with a modern city. Although separated by 2,000 years, both rely on connected roads, reliable water systems, public spaces, and careful planning. The same engineering principles still shape our cities today. But as civilizations grew richer and more ambitious, one question remained: how could they build even bigger, taller, and more extraordinary structures? By now, Egypt had mastered more than pyramids. Look across this construction site. temples, statues, and towering obelisks were all rising from carefully planned engineering. Step inside the finished temple complex. Every towering column, sacred courtyard, and massive gateway was designed to inspire awe while guiding thousands of visitors through a carefully organized space. But some of Egypt's greatest achievements began long before construction even started. Here in the Aswan quarries lies an unfinished giant. Carved directly from solid granite, this single obelisk reveals just how ambitious Egyptian engineers truly were. Now watch how they moved these enormous monuments. By pulling massive wooden sledges across water-soaked sand, hundreds of workers reduced friction enough to transport stones weighing hundreds of tons. Moving the stone was only half the challenge, the Nile carried it the rest of the way. Look around this cargo barge. Instead of carrying grain or pottery, it's transporting gigantic limestone blocks along Egypt's greatest natural highway, the Nile River. Now compare the two routes. Dragging heavy stone across the desert demanded tremendous effort, while the river allowed enormous cargo to float with far less resistance and far greater efficiency. Not every civilization relied on rivers in the same way. Far to the east, another skyline began taking shape. Rising above the city, this stepped ziggurat became the unmistakable symbol of Mesopotamian engineering. Now stand at the summit. From here you can see how canals, marketplaces, neighborhoods, and defensive walls all radiated outward from the city's towering center. Some ancient cities reached upward for religion, while others may have reached upward for something even more extraordinary. Before you stands one of history's greatest mysteries, the legendary Hanging Gardens of Babylon. Whether they truly existed remains debated, but the engineering idea is extraordinary. Look inside the cross-section. If the gardens were real, engineers may have lifted river water through chain pumps and hidden channels, allowing trees and flowers to flourish high above the dry landscape. While Babylon imagined cities filled with greenery, another civilization believed mathematics itself could shape the perfect city. Notice the circles, straight lines, and precise measurements covering the ground. Greek engineers believed every successful city should begin with careful planning, not guesswork. Now walk through the finished square. Shaded walkways, fountains, marketplaces, and gathering spaces were arranged at a human scale, making the city both beautiful and comfortable to live in. But the Romans would soon discover a material that changed construction forever. Take a closer look at what's being mixed here. Volcanic ash, lime, and stone don't seem remarkable on their own, but together they created one of Rome's greatest inventions. Compare the two construction methods. Instead of stacking countless stone blocks, Roman concrete could be poured into forms, creating stronger structures with greater speed and flexibility. That new material unlocked another revolutionary idea. Watch carefully as the final stone is lifted into place. This small block at the very top is the keystone, and everything depends on it. Now follow the glowing arrows. Instead of forcing weight straight downward like a flat beam, the arch redirects compression safely through its sides and into the foundations below. Once engineers mastered the arch, they began dreaming much bigger. Step inside the Pantheon and look up. This enormous concrete dome has remained standing for nearly 2,000 years, astonishing visitors even today. Here's the hidden secret. The dome grows lighter toward the top, while thicker concrete at the base and hidden structural rings keep this massive ceiling stable without modern steel. Roman engineering wasn't only about impressive buildings, it also connected an entire empire. Walk across this Roman bridge and notice the constant flow of merchants, soldiers, and travelers. Strong bridges didn't just cross rivers, they connected entire civilizations. Now compare it with a modern bridge. Different materials, different appearance, but the same principles of arches, load transfer, and solid foundations continue supporting the bridges we build today. The engineering ideas of the ancient world would survive for centuries, waiting to inspire the next generation of builders. Take a look around this crowded city. Every empty space has disappeared, new homes are packed tightly together, and the protective city walls leave nowhere else to grow. So ancient builders found a clever solution, or they built upward. By adding new floors above shops and homes, cities could welcome more people without expanding beyond their walls. Long before skyscrapers, cities were already learning to grow vertically. Building upward solved one problem, but it also changed the way people lived. Standing before this Roman apartment building, it's hard to believe people were already living several stories above the street nearly 2,000 years ago. Now look inside. The lower floors housed busy shops, the middle levels offered more comfortable homes, while the highest floors became smaller, crowded apartments reached by long staircases. The world's first apartment buildings already reflected differences in wealth and lifestyle. Transition. As more people crowded into cities, another challenge became impossible to ignore. Notice the long line forming around this single well. Every family depends on the same water source, and as the city grows, that supply is stretched to its limits. Then everything changes. Fresh water arrives continuously through the aqueduct, flowing into public fountains by gravity alone and transforming daily life across the city. Rome didn't carry water to its people, its engineering brought the water to the city. But water wasn't only something cities needed, it was also something they had to survive. Watch the river as the storm rolls in. The water is rising quickly, and every street, home, and marketplace now lies in its path. Here's the engineering behind the rescue. Levees, drainage canals, retaining walls, and spillways work together to guide floodwater safely around the city instead of through it. Sometimes the smartest way to defeat nature isn't to stop it, but to redirect it. Floods weren't the only disaster ancient engineers feared. Fire spreads frighteningly fast through these narrow streets. Wooden rooftops, crowded buildings, and strong winds turn a single spark into a city-wide emergency. Now compare the rebuilt city. Wider streets, more stone construction, and open fire breaks slow the flames, giving people far better chances to protect their homes. Some of history's greatest engineering lessons were learned only after devastating disasters. Keeping people safe was only one part of running a successful city. From this viewpoint, the marketplace looks like the city's beating heart. Every road seems to lead here as merchants arrive with food, tools, textiles, and supplies. Walk through the market and you'll discover goods from across the ancient world: silk, spices, glassware, ivory, and bronze, all meeting in one remarkable place. A great city wasn't measured only by its buildings, but by everything that flowed through them. Transition. Those remarkable goods had traveled incredible distances before reaching these market stalls. Follow the glowing lines across this map. They connect distant civilizations through an enormous network of roads and sea routes stretching across continents. Now step onto the Silk Road itself. Camel caravans carried silk, spices, paper, and precious goods across deserts and mountains, linking cultures thousands of kilometers apart. The Silk Road carried far more than merchandise, it carried ideas, inventions, and cultures. Many of those journeys ended at places where land met the sea. Look across this busy harbor. Merchant ships arrive one after another while cranes, warehouses, and dockworkers keep goods moving without pause. Now look inside the harbor's design. Breakwaters calm the waves, cranes lift heavy cargo, and organized warehouses keep trade flowing quickly and efficiently. A successful harbor wasn't just a place to park ships, it was a carefully engineered machine. Moving cargo efficiently required another brilliant invention. Watch this enormous wooden wheel slowly turn. As workers walk inside it, the entire crane begins lifting stone blocks that no person could raise alone. Here's why it works. Pulleys and counterweights multiply human strength, allowing a small team to move loads that once seemed impossible. Simple machines didn't make people stronger, they made their strength work smarter. After materials arrived and buildings were completed, one final challenge remained. Step inside this warehouse. Every sack of grain, amphora, textile, and clay tablet tells the story of a city carefully tracking its resources. Now compare it with a modern distribution center. The tools have changed, from clay tablets to barcode scanners, but the goal remains exactly the same: store, organize, and deliver goods efficiently. Modern supply chains didn't appear overnight, they evolved from systems first developed thousands of years ago. With cities now mastering trade, logistics, and engineering, humanity was ready for an even greater leap in innovation. Walk through these silent streets for a moment. The Roman roads remain, But the bustling markets, flowing fountains, and crowded forums have all but disappeared. But the story didn't end here. Inside quiet monasteries, monks carefully copied ancient engineering manuscripts, preserving ideas that might otherwise have been lost forever. Empires can fall, but knowledge can survive. As Europe slowly recovered, new towns faced a challenge that demanded a different kind of engineering. Look across this open settlement. With no walls for protection, every approaching rider sends villagers scrambling to gather their families and supplies. Now compare the same town behind its new defenses. Thick stone walls, watchtowers, gatehouses, and moats transformed vulnerable villages into fortified medieval cities. In the Middle Ages, a city's strongest building wasn't its palace, it was its wall. Once cities became safer, engineers turned their attention to even stronger fortresses. Watch this castle rising stone by stone. Far more than a royal residence, every wall, tower, and scaffold is part of an enormous engineering project. Now look inside the fortress. Drawbridges, portcullises, wells, storerooms, and arrow slits were all carefully positioned so the castle could withstand long sieges. Every part of a medieval castle had a purpose, even the rooms you couldn't see. Transition, while castles protected kingdoms, another kind of building reached toward the heavens. Raise your eyes to this enormous cathedral. Its soaring arches and towering walls seem almost impossible for stone alone to support. Here's the secret hidden behind the walls. Flying buttresses carry the roof's weight outward into massive support piers, allowing builders to create taller interiors filled with brilliant stained glass. Without flying buttresses, many of the world's greatest cathedrals could never have stood. As magnificent buildings reshaped city skylines, engineers were also finding new ways to connect communities. Notice the travelers waiting beside the rushing river. Trade, pilgrimages, and daily life all come to a halt because there's simply no safe way across. Now step onto the finished bridge. Stone arches carry shops, homes, merchants, and travelers across the river, turning a dangerous crossing into the busiest part of the city. Some medieval bridges became entire neighborhoods, not just places to cross a river. Transition, soon, Europe would rediscover ancient ideas and use them to build an entirely new future. Open the chest and look at what's inside. Ancient manuscripts from Egypt, Greece, and Rome are being studied once again, bringing forgotten knowledge back into the light. Now compare the old drawings with the new blueprints. Renaissance thinkers didn't simply copy the past, they refined ancient ideas into better designs for a changing world. Innovation often begins by rediscovering what others almost forgot. Among the brilliant minds of this new age, one engineer imagined machines centuries ahead of his time. Step inside Leonardo da Vinci's workshop. Everywhere you look, unfinished machines, gears, bridges, and sketches reveal a mind overflowing with ideas. Now study the comparisons on the wall. Many of Leonardo's imaginative sketches resemble helicopters, tanks, and modern bridges that wouldn't become reality for hundreds of years. Great inventions often begin as impossible sketches. Brilliant ideas are powerful, but only if they can be shared. Watch the printing press at work. With every pull of the press, engineering books that once took months to copy can now be reproduced again and again. Follow the glowing paths across Europe. Printed books spread through universities and workshops, allowing builders, architects, and scholars to learn from the same knowledge. The printing press didn't just spread books, it accelerated human progress. That shared knowledge soon inspired one of the greatest engineering achievements of the Renaissance. Look up at the enormous dome rising over Florence. Remarkably, it's being built without the giant wooden scaffolding that many believed was essential. Now examine the cutaway model. Brunelleschi's double-shell dome, hidden support ribs, and clever herringbone brick pattern allowed this masterpiece to support itself as it grew. Brunelleschi solved a problem that had puzzled builders for generations. By now, cities themselves were beginning to change. Look across this changing skyline. In just a few generations, quiet Renaissance streets are giving way to factories, railways, and neighborhoods growing faster than ever before. Now step inside the factory. Steam engines replace countless hours of manual labor, turning heat into mechanical power that keeps entire workshops running day and night. For the first time in history, machines, not muscles, became the driving force behind city growth. Power alone wasn't enough. Cities also needed a stronger material to build their ambitious future. Watch the glowing stream of molten iron pouring into its molds. This fiery process is creating a material that will reshape bridges, factories, and entire cities. Compare these two bridge designs. Stone had served builders for centuries, but cast iron could span greater distances with lighter, more elegant structures. Iron didn't just replace stone, it expanded the limits of what engineers believed was possible. Before long, those new possibilities became reality. Standing before the Iron Bridge, you're looking at a bold experiment that challenged centuries of traditional bridge building. Now watch what happens once it opens. Merchants, travelers, wagons, and cargo move continuously across the river, turning a single bridge into an engine of economic growth. Sometimes one bridge can transform an entire region. Soon, engineers found an even faster way to connect cities. Listen to the hiss of steam as this locomotive prepares to leave the station. For many people, travel is about to become faster than they ever imagined. Follow the glowing railway lines across the map. Wherever the tracks spread, towns expanded, industries flourished, and distant cities became closely connected. Railways didn't just connect places, they connected opportunities. But rapid growth created a problem no railway could solve. Take a look around this crowded intersection. Factories, homes, and warehouses fill every available space, leaving builders with nowhere else to expand. So where could cities grow next? As the stickman looks toward the open sky, the outline of future skyscrapers hints at a bold new direction, building upward instead of outward. When cities ran out of land, they discovered a new frontier above their heads. The answer to that challenge would begin with an extraordinary material. Step inside this steel mill. Massive rolling machines are producing strong, precisely shaped beams that will soon become the backbone of an entirely new kind of building. Now compare the two structures. Thick stone walls could only support a limited height, but a steel skeleton carried the weight internally, allowing buildings to rise far higher. Steel freed buildings from the limits of heavy stone walls. But steel itself wasn't enough, it also needed the right design. Look up through this forest of steel columns and beams. What you're seeing is the hidden framework that gives every skyscraper its incredible strength. Follow the glowing load path. The roof transfers its weight into the steel columns, down through the foundations, while the outer walls become little more than protective skin. A skyscraper stands because of the structure you rarely see. Even with stronger buildings, another obstacle remained. Imagine climbing these stairs every day. By the 15th floor, even the most determined workers are exhausted before reaching their offices. Now watch the elevator glide upward. Thanks to Alicia Otis's safety brake, people could travel vertically with confidence, making truly tall buildings practical for everyday life. The elevator made skyscrapers useful, not just possible. With steel and elevators working together, history was ready for its first skyscraper. Standing on this Chicago street in 1885, people couldn't believe what they were seeing. The home insurance building reached 10 stories into the sky, something almost unimaginable at the time. Watch the idea spread across the world. From Chicago to New York, Tokyo, London, and beyond, cities embraced the skyscraper and forever changed their skylines. One building inspired a global race toward the sky. But the story of skyscrapers began long before steel ever existed. Take a step back through history. From pyramids and ziggurats to Roman arches, Gothic cathedrals, iron bridges, and steel frames, every breakthrough built upon the one before it. Now stand above the modern skyline. Every skyscraper around you carries the legacy of thousands of years of engineering, proving that today's tallest buildings are really the next chapter in an ancient story. Every modern skyscraper stands on 4,500 years of human ingenuity. But if this is how far engineering has brought us, imagine where the cities of tomorrow might take us next. Stand beside a modern skyscraper and one question immediately comes to mind: how can something this tall possibly support its own weight without collapsing? The answer isn't what you see on the outside. It's hidden deep within the building itself. Behind the glass walls is a giant structural skeleton. Steel columns, reinforced concrete cores, and deep foundations work together to carry millions of tons safely into the ground. Every skyscraper stands because of the invisible structure hidden inside it. But gravity isn't the only force these giants must overcome. The taller a building becomes, the stronger the wind pushes against it. Hundreds of meters above the ground, even gentle breezes become powerful forces. So how do engineers stop these towers from being blown over? Surprisingly, they don't. Instead, skyscrapers are designed to bend just a little, safely absorbing the wind's energy rather than resisting it completely. Sometimes strength comes from flexibility, not rigidity. But even flexible buildings need another secret weapon hidden high above the city. Inside some of the world's tallest skyscrapers hangs a gigantic metal sphere. At first glance, it looks like an enormous piece of modern art. In reality, it's one of the smartest engineering inventions ever created. Called a tuned mass damper, this massive weight gently moves opposite the building's motion, reducing sway and making the entire tower feel far more stable. Sometimes a single moving object can steady an entire skyscraper. Yet wind isn't the only challenge engineers prepare for. In earthquake-prone regions, the danger comes from below. Powerful seismic waves can shake the ground without warning. Rather than fighting the earthquake directly, engineers found a much smarter solution. Special base isolators and energy-absorbing dampers allow the ground to move while protecting the structure above from much of the violent shaking. The safest buildings don't stop earthquakes, they separate themselves from them. Even after solving wind and earthquakes, one everyday challenge still remains. Imagine living hundreds of meters above the street. How does clean water travel all the way to the highest apartment? The answer lies inside an invisible network hidden behind the walls. Powerful pumps push water upward through pressure zones and rooftop storage tanks before gravity carries it to every sink, shower, and office below. Every drop of water reaching the top floor is powered by carefully engineered systems working around the clock. Water is only one lifeline. Next, we'll discover how electricity flows through these vertical cities like a living nervous system. Flip a light switch in a skyscraper, and electricity appears instantly. But behind that simple action lies a vast network hidden deep inside the building. Just like our bodies need veins to carry blood, skyscrapers need their own pathways to deliver power. Electricity enters from the city grid, passes through transformers and distribution panels, then travels upward through electrical risers before branching into every room, elevator, and light. A skyscraper's electrical network is like a living circulatory system, delivering energy wherever it's needed. But electricity alone isn't enough. People also need something even more essential: fresh air. Walk into a modern office tower and you'll notice something surprising. Thousands of people work comfortably inside, even though many windows never open. So where does all that fresh air actually come from? Hidden ventilation systems constantly pull in fresh air, filter it, cool or heat it, and quietly circulate it throughout the entire building before repeating the cycle. Every skyscraper breathes through an invisible network of ducts, fans, and air handling systems. Now imagine moving thousands of people through this giant vertical city every single day. Every morning, crowds flood into skyscrapers, all heading to different floors. Without an efficient system, everyone would spend hours waiting. The solution transformed elevators into one of the busiest transportation systems on Earth. Multiple elevator banks, express lifts, sky lobbies, and intelligent control systems move thousands of passengers quickly while reducing congestion throughout the tower. Inside a skyscraper, elevators function much like roads and highways inside a city. But moving people efficiently means little unless they can also be protected during an emergency. Fire is one of the greatest dangers any tall building can face. That's why modern skyscrapers are designed to detect problems within seconds. Once an alarm sounds, an entire chain of hidden safety systems immediately comes to life. Automatic sprinklers, smoke control systems, fire-resistant walls, and protected stairwells work together to slow the fire and guide people safely out of the building. Modern skyscrapers aren't just built to stand tall, they're built to protect the people inside. Behind all these systems is one final layer of engineering that quietly keeps everything running every hour of every day. Behind every modern skyscraper is a control room where engineers monitor thousands of sensors, keeping every system running safely and efficiently around the clock. When you connect every hidden system together, electricity, water, ventilation, elevators, and smart controls, a skyscraper begins to resemble a living organism. Its sensors act like nerves, its pipes like veins, its ventilation like lungs, and its building management system serves as the brain, constantly coordinating everything in real time. A modern skyscraper isn't just a building, it's a living machine where thousands of systems work together as one intelligent organism. And perhaps that's the greatest engineering achievement of all. From ancient pyramids to towering skyscrapers, every generation has built upon the knowledge of those who came before, shaping the cities we call home today. For thousands of years, we've explored individual buildings, from pyramids and aqueducts to skyscrapers reaching into the clouds. But what if the greatest engineering achievement isn't a single structure at all? What if it's the entire city itself? A modern city is much more than a collection of buildings. Beneath every street and above every rooftop, countless systems work together: electricity, clean water, transportation, communication, and waste management. Like gears inside a giant machine, each system depends on the others to keep millions of lives moving every day. A great city isn't one masterpiece, it's millions of engineering masterpieces working together. But keeping an entire city alive means solving one enormous challenge every single morning. As the sun rises, millions of people leave their homes at almost the same time. Cars, buses, trains, bicycles, and pedestrians all compete for the same streets. Without careful planning, a city could grind to a complete standstill. Today's cities rely on intelligent traffic systems that constantly monitor vehicle flow. Smart traffic lights adapt in real time, buses receive priority at intersections, and public transport is carefully synchronized to reduce congestion. Instead of following fixed schedules, modern roads are beginning to think for themselves. Moving people is only one part of the challenge. Every night, another invisible system quietly powers the entire city. When darkness falls, millions of lights switch on almost instantly. Homes, hospitals, offices, factories, elevators, and streetlights all come alive together. But where does all that electricity actually come from? Electricity begins its journey far beyond the city, from hydroelectric dams, wind farms, solar parks, nuclear plants, and other power stations. It travels through high-voltage transmission lines to substations before being safely distributed to every neighborhood, every building, and eventually every light bulb you see. Every glowing window is connected to a vast engineering network stretching far beyond the city's skyline. Yet providing energy isn't enough. Cities must also confront another growing challenge, one created by the city itself. As cities expanded, roads, concrete, and glass gradually replaced forests and open land. On hot summer days, these materials absorb and trap heat, making urban areas significantly warmer than the countryside surrounding them. Engineers and architects are now redesigning cities with nature in mind. Green roofs cool buildings, vertical forests improve air quality, rain gardens reduce flooding, and solar-powered structures generate clean energy. Instead of fighting nature, tomorrow's cities are learning to work alongside it. Sometimes the smartest technology isn't adding more machines, it's bringing nature back into the city. Surprisingly, many of these new ideas aren't new at all. Ancient civilizations understood the value of shade, flowing water, natural ventilation, and public gathering spaces. As cities become smarter, engineers are beginning to rediscover solutions that humanity first developed thousands of years ago. The cities of tomorrow may use artificial intelligence, renewable energy, and advanced materials, but many of their guiding principles are remarkably old. Sustainable design, efficient water management, and people-centered planning have always been part of humanity's greatest engineering achievements. The future isn't leaving history behind, it's learning from it. And if cities continue evolving at this pace, one question naturally follows: where will humanity build next? Across the world, cities continue to grow. Every year, more people move into urban areas, while the amount of available land stays the same. Engineers are once again facing a familiar challenge: how do you create more space without creating more land? The answer may not lie in just building higher. Future cities could expand underground with transportation networks, across oceans on floating communities, and through elevated neighborhoods connected by sky bridges. The cities of tomorrow may grow in every direction at once. But the buildings themselves are evolving too. Imagine living inside a building that grows food, collects rainwater, produces its own electricity, and helps clean the air around it. It sounds like science fiction, but pieces of that future already exist today. Around the world, architects are building vertical forests, net-zero skyscrapers, and intelligent buildings that consume less energy while producing more of their own resources. Many concepts once imagined for the future are quietly becoming reality. The future often arrives long before most people notice. And perhaps humanity's greatest construction project won't even be on Earth. As we dream about returning to the Moon and traveling to Mars, engineers face an entirely new question. How do you build a city where there's no breathable air, no flowing water, and no familiar environment to rely on? Whether on Earth or in space, the fundamental principles remain unchanged. Future habitats will still depend on structural strength, clean water, reliable energy, efficient recycling, and careful planning, the very same engineering ideas first explored by ancient civilizations thousands of years ago. The next giant leap into space will stand on foundations built by the past. Looking back, one remarkable pattern becomes impossible to ignore. Every era introduced a breakthrough that seemed impossible at the time. The pyramids, Roman aqueducts, Gothic cathedrals, iron bridges, steel skyscrapers, each generation pushed engineering a little further than the one before. No engineer builds alone. Every discovery builds upon earlier discoveries, and every generation inherits the knowledge of those who came before. Human progress is not a series of isolated achievements, it's one continuous story stretching across thousands of years. Every great engineer is both a student of the past and a builder of the future. Which brings us back to where our journey first began. From a single stone block to cities visible from space, humanity's engineering journey has never truly been about buildings alone. It has always been about solving problems, sharing knowledge, and imagining a better tomorrow. The pyramids, Roman roads, soaring cathedrals, towering skyscrapers, and future space cities are all chapters of the same unfinished story. Somewhere, perhaps even today, someone is imagining the next great engineering marvel, one that future generations will one day study just as we study the achievements of the past. Every wonder of tomorrow begins as an idea today. So the next time you look at a skyline, remember, it isn't just a collection of buildings. It's the story of humanity's greatest ideas, still reaching higher. And perhaps the next chapter will be written by you.